Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of scientific notation. This is standard 8.2C in the great state of Texas, and we are using item number 18 off the 2017 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have the mass of a textbook, and it's very tiny. We got a metric ton, which we don't use to measure mass, but it's 0.00165. So how is this number written in scientific notation? So you notice we're going to get our 165. That's going to show up in all of our answer choices. But the question is, how do we write it properly? So let's first take a look to see what this number is. 0.00165. Let's make sure all of those scientific notations actually work, then we'll figure out what the proper one is. All right, so obviously we've got our ones place here. This is our tenths, hundredths. We get to our thousandths, 10,000ths. So it looks like that last one is going to be 100,000. So 165 100,000ths. Yeah, it's kind of a pain to have to write a place value chart just to name it. So scientific notation lets us take really, really small numbers, and that's what we're doing here. Or you can also use really, really large numbers and make it a little bit more manageable. So let's see what 165 times 10 to the 5th looks like, okay? So 165 times 10 to the 5th. So the decimal goes right there. So when we're going to do times 10 to the negative 5th, right? If you do 10 times 10 to the 5th, you're going to move the decimal over to the right because you're multiplying by 10, you're adding zeros. So if you do multiply by 10 to the negative 5th, you're actually dividing by 10 each time. You're moving the decimal over 5 times to the left. 1, 2, 3, 4, 5. All right, so this ends up with the correct number. We'll question mark that. Let's check our 1.65 times 10 to the negative 3. So I'm just going to line up the 165. But we're starting with the decimal right there. Times 10 to the negative 3. So negative, we're going to go 1, 2, 3. Notice we're ending up with the same answer choice. I have a sneaking suspicion we might get the same thing with the other two. 16.5. times 10 to the negative 4. All right, so let's put a decimal right there. 1, 2, 3, 4. It's looking good. All three of those are getting us possibilities there. So 0.165, 65 times 10 to the negative 2. 1, 2. All right, so that doesn't help us. All four of them, if you kind of factor them out a little bit, end up with this 0.00165. So what we know is that we can guarantee that at least every single number is going to have a digit in the ones place. Now, it could have a digit in the tens and the hundreds. It could have a digit in the tenths or 100ths, but sometimes they don't. But the foundation of everything we start with is in the ones place. We start counting in the ones place, which means when we're doing our scientific notation, we always just go to the ones place right here, and then we put the decimal after that, which means G is actually the correct answer.